Hi friends, I think you have watched my last video. If you haven't watched my last video, which was the basics upon the Cartesian coordinate system, so please do it to complete it first. After that, come back to this point. In today's lecture, I am going to cover the differential length, area and the volume in case of the Cartesian coordinate system. So for that, I am going to draw the Cartesian coordinate system again right now. Let me draw it first, then I will explain. See, this is a three-dimensional vector space, okay, also known as the Cartesian coordinate system. Cartesian coordinate system can also be known as a XYZ coordinate system. So let us say this is X, this is Y, and this is the Z. And inside the Cartesian coordinate system, as in my last video, I drew a block, right? So let me draw the block first. Okay, this is a large block. Okay. Basically, the block means here nothing but a volume in the Cartesian coordinate system. In the Cartesian coordinate system, I am I am considering a volume that is nothing but a block. Okay, and definitely this block has three dimensions: length, width, and height. So definitely, as this block has the three dimensions, that three values will be assigned in the three dimensions, like the length of this block, it has a length, it has a width, and it has a height also. So the length is along in the direction of y, so I am taking the length as y. Okay, that is the small y. As the width is along in the direction of x, so that's why I am taking the width as x, and the height is in the direction of z, so I am taking the height as z. Small x, small y, and small z. Okay. One more thing, these are in the capital. Okay, this XYZ coordinate system, X, Y, and Z are in the capital, and the width, length, and height of this block is in the small. X, Y, and Z corresponding width, length, and the height. Now, understand this point very clearly. I am considering now a small piece inside this large block. Say, like this. This is a small piece I have considered inside this large block. Now, think that, let me just drag it more larger. Okay, just a minute. So as it is a small piece inside this large block, so that means this is nothing but a small block. Now the small block has a small length, small width and the small height, because the small block has a small volume also, right? So actually the word differential here, this word differential means small. Differential means small. Okay. So that's why inside the large block under the Cartesian coordinate system, I have considered a small block of small width, base and the height. Okay. Then means definitely the small block has a small volume. See, now let us first denote the width, length and height first for the small block. Okay. Say this surface, this is 1, 2, 3, 4 surface. I am just denoting it 1, 2, 3, 4. And this one is the 5, 6, 7, 8, or the 1 dash, 2 dash, 3 dash, and the 4 dash point is invisible. Okay. Now, the small blocks has the small length. What is the small length? See, the large block has the large length, that is the y. So for that, for the small block, it has the small length, that is the del y. In the same direction, that is what? This is the dy, because the small block has a small length. As the large block has the large length y, the small block has the small length of dy. Now, as the large block has the large width of x, hence the small block has the small width of dx. Similarly, as the large block has the large height z, that's why the small block has the small height of dz. Okay, right. These are the three things I have mentioned over here. Now, as the small block, see the large block or the small block, whatever the large block or the small block I am talking about, it has the length, area and the volume. So as this small block has three lengths, it has also has the three areas. Not only three areas, it has actually six areas, six surface areas. Among the six surface areas, three are visible. So that's why I am talking about the three areas. Okay, that means what are those three areas? These are these. See, 1 dash, 2 dash, 1, 2. This is one area that is visible. I am talking about the visible area. Also, it has the three more areas in the opposite direction. But in this case, 1 dash, 2 dash, 1, 2, this is a visible area. And you know that area is a vector. As the area is a vector, I have already discussed about it in my last video, that the area is a vector. That means this area has a direction. What is the direction? The direction of any vector area is nothing but the perpendicular to this area. What is that? That is nothing but this. Okay. And also 2 dash 3 dash 2 3, it is also area. It has also a direction that is directed towards this. And also 1 2 3 4, this is also area, and each direction is directed toward this. See, actually, in case of the area vector, the direction is perpendicular above the plane. Okay, above the area plane. These all of these are nothing but the perpendicular. Okay. So let me draw it first. and these are the directions. As the direction is denoted by the unit vector, so I can write it as acha, okay. Before that, let me write this also for area, a small concept over here. If this is a area, that is the direction of the vector area I'm talking about. So small concept is about the direction of the area vector. If this is a area, say this is a area, and it has the length and width as a and b. If this happens, then and it is a vector area or the area vector. So as this is a area vector, that means the direction is perpendicular to this plane. The direction is perpendicular to this plane, like this. And the direction is denoted by the unit vector. I am writing here a of n, that is the normal to this plane. So I can write this area, this total area, or this area vector as any vector has a magnitude and a direction. So that means this area vector, that is S vector, it is a vector, that's why I am giving a bar over S. So that means that is S is a vector. See, this is the vector that must have the magnitude. What is the magnitude? A cross B or AB. AB is the total area. Okay, and as well as the direction. Direction is A of n. That's the notation in case of the area vector. Area vector I am talking about. In case of the normal area, you will only write the AB. In case of the area vector, you have to write the direction also, and for that you have to take the perpendicular above the area plane. Okay, so that means I am writing the important note here. That note is direction of the area vector okay, I think it will not be covered here. Just a minute. This one here. Yeah, okay. The direction of the area vector, direction means in this case, this is the AN of area vector is outwards perpendicularly. With respect to what? With respect to the area plane. Whatever I am writing, the same concept will be implemented in this case also. That is the differential length, area, and volume. So I am writing here that if I consider this area as a vector, AB as a vector, then what will be the direction? And this is a vector, it must have a direction. Its direction will be the outwards with respect to the AB plane, right? So that means in this case also, if I consider, see now look at here. If I consider 1 dash 2 dash 1 2 this plane, this vector, this is an area and it has must have a direction and it is a vector. So its direction is denoted by the outwards vector like this. And now consider this is a unit vector because any direction is given by the unit vector and the direction is towards the z. Okay, now the direction is towards the z direction. So area vector, I'm sorry, the direction of the area vector is a unit vector and that is also towards the z direction, that can be denoted as it. We have already talked about it in my last video. In the similar way, 1, 2, 3, 4, this area is also a vector and it must have a direction, as that direction is along the direction of the x. So I can write it as a of x. That is the unit vector towards the x direction, because the unit vector is only used for denoting the direction. Okay. Only not only that, also for 1, 2, 3, 2 dash 3 dash, for this area. For this area, if the direction is denoted by the unit vector and that is also towards the y direction, this is the y direction, so that can be denoted as a of y. Okay, these are the three directions or the three unit vectors which are also perpendicular to each other. That means they obeys the rule of the orthogonality. Definitely, any unit vectors obeys the any two unit vector obeys the rules of the orthogonality or the RH rule. Okay, and these vectors is specially defined here. For this case, these vectors are specially defining the direction for the corresponding surface areas of this small differential block. Okay, now from here only I can talk about the differential length, area and volume. See, if I want to talk about the differential length, area and volume, we must have to consider a differential block or the small block inside this Cartesian coordinate system, because only a block or only a block under the Cartesian coordinate system must have a length, area and volume, three things. A three-dimensional block only have a block of the three dimensions only have the differential length, area and volume. Any surface or any straight line don't have all these parameters, length, area and volume. Okay, so that's why I have considered a small block here, because only by considering this small block I can talk about length, area and volume, all these three parameters. Now let us dive into exact exact formulas for this length, differential length, area and volume. First of all, I will talk about the differential length. Okay, so differential length, see, length is a vector. Okay, so as the length is a vector, that means differential length is also a vector. So first of all, first point I can write over here, that is length is a vector. Length is a vector. If length is a vector, then the differential length that can be denoted as a small dl, it is also a vector. And it is a vector, it has been given a bar over the dl. A bar has been given over the dl, that is the length. Just a minute, I have to drag it a little bit so that I can get more space. Okay, so now I am talking about the okay, differential length over here, and as the differential length is a vector quantity, I have given a bar over there. Without doing this, I can directly draw a line over that. So let me draw a line. Okay, now as the differential length is a vector, it must have a magnitude and the direction. See, I am talking here about the differential length. So as I am talking here about the differential length, I will only consider this small volume or the small block, not the large block. Now large block has been used here to draw the small block actually. So by using the small block, I can see there are the three lengths. What are the three lengths? Width, length and the height. These are the three lengths in case of this small block. Now if I consider this small block, I can write the differential length as dl. If I consider the length, that means the dy, then it is a vector, so dy must have a direction also. And see, this dy is in the direction of what? In the direction of y. So dy is in the direction of y. So I can write the differential length for along the y direction like dy and the unit vector of y. In a similar way, I can write the differential length also in the direction of x can be written as dx in the direction of x, and in the similar way differential length in the direction of z can be written as dz in the direction of z. Okay, as these three are the vectors, it must have the magnitude and a direction. Okay, now these are the see these are the three differential length along the three direction. Okay, now actually I can denote it as a differential length in the direction of y, differential length in the direction of x, and in suffix I can write here that is the z, differential length into the direction of z. Now if I talk about the total differential length, that is the dl. dl will be nothing but the summation of all these three lengths, that is the dlx plus dly plus dlz. Okay, if this occurs, then I can write it as dx in the direction of x, dy in the direction of y, dz in the direction of z. This is the actual formula in case of the differential length inside the Cartesian coordinate system. Okay, and this is very much important one. As the differential length is a vector, and I am considering the three-dimensional Cartesian plane, that is the xyz coordinate. So that means this differential length vector must have the three factors along the direction of x, y, and z, right? Those three factors are dx, dy, and dz along in the direction of x, y, and z respectively. Okay, this is about the differential length. Now, now I will talk about the differential area. We have talked about the differential length. Now let's dive into the differential area. So now let us consider differential area. Okay, this is the differential area. Okay, to understand this differential area, I am drawing the coordinate again. Actually, it is required for that. This was the x, this was the y, and this is the z. Okay. See, coming back to the small block, which has been colored here green. So this green colored small block, just a minute. Okay. For this block, I have talked about the differential length. Now let's come back to the differential area. If I talk about the differential area is nothing but the areas along with the three directions respectively. Now, what are those three areas? That is 1, 2, 3, 4. That is the area that has been directed toward the direction of x, ax, and another area is 2, 3, 2 dash, 3 dash. This is also one area that is in the direction of ay, and one another area is 1, 2, 1 dash, 2 dash. This is another area which has been directed in the direction of az or in the direction of z. Okay, so these are the three areas that has been visible over here. So I am drawing these three areas differently on this coordinate system again. So first area, what you can see over here, that is this. This is one area that you can see, and see, this is one area that has been denoted by 1, 2, 3, 4 over here, right? So that means the area I am talking about is 1, 2, 3, 4 over here. Now this is the area. First let us talk about it, and this is the area that I can see for this differential block, and the another area that I can see is 2, 3, 2 dash, 3 dash. So let me draw it now. 2, 3, 2 dash, 3 dash. For that I need a okay. There is the 2, 3, 2 dash, 3 dash. 2, 3, 2 dash, 3 dash. Okay. This is the another area, and the last one area is that has been left. That is what? This 1, 2, 1 dash, 2 dash. Okay. So let me draw this area also. I think I can't draw like this. What is that area? That is, see, the last area is this. This was the another area that I can see over here. That is 1, 2, 1 dash and 2 dash. 1, 2, 1 dash and 2 dash. Okay. So these are the three areas that has been exposed for this small differential block. These are the three areas. Though this small differential block has another three surface areas in the opposite direction, which is not exposed basically. I am talking about the exposed area only right now. So these three areas are actually not the scalar quantity. Area is a vector quantity. Now as this area is a vector quantity, so I have already told you the direction of a area vector is what? Perpendicular above the same surface. Okay. So for 1, 2, 3, 4 area vector, The direction of this area vector is what? That is the perpendicular to this surface. Perpendicular to this plane. What is that? Is nothing but the in the direction of what? This in the direction of x, right? For similarly, to for 2, 3, 2 dash 3 dash for this area, the direction of this area is what? Towards the y direction, which is nothing but the perpendicular to the to this plane 2, 3, 2 dash 3 dash, and the another for that last area 1, 2, 1 dash 2 dash, the direction is what? Direction is towards the z direction. Okay, direction is what? Towards the z direction. See, these three are the perpendicular actually above the plane. Okay. Now this is what? This is the in the direction of x, that has been denoted by the unit vector in the direction of x. This is in the direction of y, that has been denoted by the unit vector in the direction of y, and this is in the direction of z, that has been denoted by the unit vector in the direction of z. Okay. So these are the three area vectors, right? I am talking about the differential area, that is the dA over here. Okay. So now let's see what are these three differential areas. Okay. For this 1, 2, 3, 4, which area has been directed, or the which area has the direction in the direction of x, that has been denoted by dA in the direction of x, right? Now dA in the direction of x, that has been denoted by what? See, whatever I have told you, the same thing I will write here. Let me first write the magnitudes. This was the dz. This was the what? This was dz, and this is the dx. This is the dx, and this was the dy. Right? Now, now tell me, what is the area vector in the direction of x, which has been drawn over here? For this, what is the area vector that has been directed in the direction of x? Okay, this area vector is nothing but the magnitude, that is the dy dz, magnitude in the direction of x. For this one, okay, I think you have understood this. Similarly, for this one, 2, 3, 2 dash 3 dash plane, for this plane, what will be the area vector? Area vector is nothing but the directed, what? Directed towards the ay. So as it is directed towards the ay, and as it is a vector, it must have the magnitude. What is the magnitude? That is nothing but the multiplication of dx and dz according to the picture. And in the direction of what? In the direction of ay. In a similar way, I can write the differential area for this plane also, that is the area or the magnitude, that is the dx dy, in the direction of what? In the direction of az. Okay. Right. See, now you might have a question in your mind. This dy dz, dx dz, dx dy, these are nothing but the scalar quantity. These portions, this is the magnitude actually, right? So dx dy or the dy dz, dx dz, and the dx dy, these three things, dy dz, dx dz, and the dx dy, these three values are nothing but the magnitude. Now, as these three values are magnitude, so you can shuffle this also. Like, you can also write it as the dz dy, no problem about it, dz dy. But the area or the unit vector, don't change the sign of the unit vector. Okay, if you write this the dz dy, this is not the wrong, but the unit vector will be the same direction. Similarly, for this you can also write the dz dx also, no problem about it, no confusion about that. In the direction of dy, for these things, for dA in the direction of az, you can also write it as dy dx. That is not wrong, in the direction of az. But don't change the sign of this. Means, don't write that's the dz dy in the direction of the minus ax. No, this is not. Actually, this is wrong. The wrong one is, I am also writing the wrong one. This is not equal to, some people think that the dy dz in the direction of x. Okay, so then you can write the dz dy in the direction of minus ax. No, not like that. Similarly, this is not equal to dz dx in the direction of the minus ay. No, not like that. Okay, and for this, some people may write that dy dx. See, they think that the dx dy is in the direction of az, then dy dx will be in the direction of the minus az. But this is also wrong. These three things are the wrong one. Okay, remember this point. There is a very much misconception among most of the students, so remember this point very clearly. Okay, now these are the three differential areas along three directions. Okay, and one more thing to note, I want to mention over here. So let me write this to note first. Okay, whatever I have already discussed. Just a minute. Okay, two notes. What happening? Notes. Okay. Number one is whatever I have already discussed, that is the area vector is always normal to the surface. Okay, is the area vector. Area vector means what? This x, ay, and az. That is the normal to the surface. This normal with this dx dy surface, dx dz surface, dz dx surface, whatever I have shown over here. That is, area vector is always normal to the surface and taken away from it. Taken away from it, it means the direction of this area vector is outwards. Is outward, not the inward. Not in this direction. Not in this direction. It is outward, in the direction of outward with respect to the plane. With respect to the plane or the surface. Okay, so that's the first point that I am going to write over here. That is number one. See, the area vector is always normal to the surface and taken away from it. Taken away means you can also write it as outward from it. Okay. Now, I'm sorry, this is the area. Now, the another thing is, which is very, very important and very much interesting also. The another thing is, see, in case of the Cartesian coordinate system, you can see there are the three parameters, right? What are those three parameters? X, Y, and Z. X, Y, and Z. These are the three parameters in case of the Cartesian coordinate system, right? These are the three parameters. Now, among these three parameters, if two parameters gives the area, two parameters, any two parameters, you can take x, y, or you can take y, z, and you can also take the x, z. If the two parameters gives area dimensions, then the remaining parameter one remaining parameter will give what? Will give the direction of the area vector. The two parameters, any two parameters, see, I will give you a example. Don't worry about it. Now, if the any two parameters, you can take it as yz as you have selected. Let's say you have selected xy. So you have selected xy, which will give you the area dimension. Okay. If the xy give the area dimensions, then the left one parameter. What is the left one parameter? That is the z. Then the parameter z will be used to give the area directions or the direction of the area vector. The example is like you have already seen that in case of the differential area, see the differential area. In case of the differential area, that is the in the direction of, I'm sorry, if you take that xy to give the area dimensions, xy to give the area dimension means if you take the dx and dy, as I am talking about the differential area, I am taking dx dy. Okay, that means I have picked up the x and y to use to be used as the area dimensions. Then the left hand parameter, what is the left hand parameter? Left hand parameter is z. Then the z will be used to give the area vector direction. That means that will be in the direction of az. Here what I have done, I have done I have used x and y. Xy used for what? Area dimension. And the left one parameter, that is the z used here to give the area direction. Okay, see, this is the thing here. Okay, that's what I have written over here. These are the two important notes, right? And that's all about the differential area also. Now let's come back to the last one or the left one topic, that is the differential what volume, which is very easy. Just a minute. Okay. Differential what volume. Now differential volume, I have directed it as a dV. Now see, the most important point about the differential volume is not the vector quantity, it is the scalar quantity. Okay, the volume, as the volume is not the vector quantity. So the important thing that I can write over here in red color. Red means important, right? That is, this is what scalar quantity. It is not the vector quantity, it is a scalar quantity. Now see, as I am talking about the differential volume, that means you have to consider the differential block only, not the total block. Like this block. This is this block of the green color. You have to consider it. You have to consider the block of the green color as you if you consider the block of the green color, then the volume of the block of the green color or the volume of this small block will give you the differential volume. Okay, the volume of the small block will give you the differential volume. Now, what is the volume of the small block? You can see that is volume is what? Length, width and height. The volume is length, width and the height of the differential block. So what is the length? That is the dy, width is dx and the height is dz. Now, that means dx, dy and dz will give you the differential volume. That's what I will write over here. See, dv is, that is nothing but dx, dy and dz. And it doesn't have any directions because differential volume is a vector, is a scalar quantity, not the vector quantity. Okay, let me block these three things also, because this is actually the main formula of the differential area and this is the formula of the differential volume. Okay, important one. Okay, and for length I have also already, I think, boxed it. Okay, the 3 star. Don't worry, I will give you the 3 star also here. For differential length, I have considered the three directions. For differential area also, as it is a vector quantity, I have considered the three directions. But the for case of differential volume and it is a scalar quantity, I will not consider the directions or the unit vector over here. Okay, that is a scalar quantity, right? I think you have understood differential length, area, and the volume. Though there is another method and which is also the easier method to solve the numerical on the differential length, area and volume. I will discuss about it later on. After completing the total coordinate system, I will give you a chart, small chart to remember all these formulas. Okay, that will be your what? Brahmastra, right? Don't worry about it, guys. Right now, I am concluding this session. If you have liked it, you can smash the like button, and if you have any doubts, if you consider, if you are suffering from any kinds of questions depending upon the topics, whatever we have discussed today, you can put your doubts due to your questions in the comment sections. I will definitely read it and try to solve your doubt. Okay, that's all for today, and hope we will meet you soon in the next session. In the next session, I will start from the next coordinate system because our Cartesian coordinate system is over. I will jump into the next coordinate system, that is the cylindrical coordinate system. Okay, so that's all for today. Hope we will meet soon. Thank you.